Hi everyone, my name is Ge Yuying and I'm going to present our work about video language pre-training. Previous dual encoder methods used to separate encoders to contrast video level and sentence level representations, but ignore local information and cross-modality associations. Joint encoder methods concatenate videos and texts as inputs to a joint encoder for cross-modality fusion, but they have low efficiency for retrieval. In this work, we design a proxy bridge format to promote local feature learning and fine-grained video-text associations. Bridge format can be removed for retrieval to maintain high efficiency. Given a video and its text description, we observe that the noun and verb phrases carry rich semantic information. So we construct noun questions and verb questions by erasing the corresponding phrase from the sentence, and the correct answer should be the erased phrase. We propose a parametric pretest task, multiple choice questions, using bridge format to answer the questions constructed by the text features while resulting to the video features. Besides a text format and a video format, we train a bridge format to select the correct answer from multiple choices by visual reasoning with local video features. Such a pre-training objective enforces video format to capture detailed spatial content and temporal information so that bridge format can answer noun and verb questions correctly. The semantic associations between video text intermediate tokens are enhanced while the proxy task of questions and answers. Bridge format is removed for downstream retrieval. The pre-training pipeline optimizes three contrastive laws. The first one is to contrast video representations with text representations. The second one is to contrast noun-answer representations from bridge format with noun representations from text format. The third one is to contrast verb-answer representations with verb representations. Text format, video format, and bridge format each contains a stack of transformer blocks. We feed tokens from all level video block and text block into the corresponding bridge block to perform cross-modality attention. So how does bridge format answer noun questions? We visualize the cross-modality attention between the text tokens of noun questions and video tokens. We can see that bridge format attends to video patches with specific object information to answer noun questions. It shows that video format can extract accurate spatial content, and text format can understand the semantics of the question. Then how does bridge format answer verb questions? We can see that bridge format focuses on object motions of video tokens to answer verb questions. It shows that video format can capture temporal dynamics of videos. For downstream evaluation, we perform text-to-video retrieval on 4 benchmarks. In this table, the top rows show the results on the zero-shot evaluation, and the bottom rows show the results on the fine-tuning evaluation. We can see that our method outperforms all previous work by a large margin. The 3 tables show the results of text-to-video retrieval on the other benchmarks. Our method also performs the best under both the zero-shot and fine-tuning evaluation. We conduct zero-shot action recognition on 2 datasets. This task can be treated as video-to-text retrieval. Our model surpasses the competitive baselines significantly. We also evaluate the single-modality video representation of our model on action recognition with linear evaluation. Our method achieves promising results with relatively shorter video hours for pre-training. We can see that our method can also enhance video representation learning by utilizing the language semantics. That's all of my presentation. Thank you for listening.